All right, it's the Ask Them Anything panel. So ask whatever you want. We have 3 mic runners. Wow, look at this. Amazing. Mic runners are going to be busy. So let's start right off the bat. You know who they are. You've been watching them for the past 2 days. So let's start with our first question, number 3.
Question with regard to shared pointer and the atomic increment decrement. If in the language that, like for instance, a double precision number, there's no guarantee that it will be done in an atomic operation when passed, say, to a function. Why was the decision made to do an atomic increment decrement as opposed to allowing a coarser grain locking and then not incurring the overhead?
That's to support the usual thread safety guarantee. So if you've got, say, 2 ints on completely different threads that are different objects, then the threads can modify them simultaneously. Imagine that you've got 2 threads with different shared putter objects, so SP1 and SP2, and they're both copying from them or assigning to them. So read writes on different threads. But these shared putters happen to be owning the same underlying object with the same ref count. Well, copying them or assigning to them is going to increment or decrement that shared ref count. So even though the user didn't have multiple threads simultaneously partying on a single object in memory, behind the scenes they're modifying the shared variable. And so to preserve the usual thread safety guarantees provided automatically by vector and list, the STL needs to protect it with atomic operations, interlocked increment, or other platform intrinsics.
Thank you.
So if you want to apply that to something like a double, then you just say atomic double.
Is GoingNative stepping in for you?
Yeah.
Oh, okay, I didn't know that. All right.
Yeah.
Okay.
All right, 2.
No, it's fine. It's fine.
Hi, everyone. So I think we all agree that native code is great, but I just want to ask, when you're not writing native code, what languages do you guys use to get things done?
How did you get into when you're not writing native code?
This one go in order?
Z shell.
Yeah, that's right.
I don't remember the last time I actually wrote non-native code. I've modified a lot of Python code, but I don't think I actually wrote any of it. I just copied other people's. I don't understand this.
I have written Java code off and on.
And I believe you also were involved in a JVM implementation, which was written in...
which was, at the time, that was mostly written in C, some C++.
Shell script, awk, that kind of stuff.
I have the luxury of being just a C++ developer, but occasionally I write Windows batch files. I win the award for most evil.
I don't know, Python maybe. A lot of LaTeX lately. I wrote 40 lines of C# 2 weeks ago. 40.
All right, number 1.
So my question is about adoption. In my limited personal experience, I find it really hard to move. A lot of people who are native tend to be, or still are, believe it or not, C with classes or C, void star, et cetera, et cetera. And I find it very hard to move people that I work with or that I've worked with in the past towards a more modern idiomatic style. And things like Bjarne's new book or all of your work, this conferences like this help. But in your personal experience, convincing that void star guy to move forward, what are some of the things you do? How successful have you guys been in your personal experience?
It's immensely difficult, that's all I can say. And you have to think in terms of years or even decades. And you have to remember that what you call the void star guys tell each other what works and doesn't. And therefore, quite often refuse to learn new things because they know they're complicated, slow, can't be debugged, can't be tested, all the usual thing. You can sort of list what people object to. And the only thing that I found really useful is somehow figure out what a problem that the individual you're talking to have that can be solved better with C++, and then actually do it for them. And then sometimes they actually believe what they see. But there's a strong mechanism in the language world in you already knows this stuff what doesn't work, so I don't have to try it. And that's the mechanism you have to, that's the sort of psychological mechanism you have to break.
I find that that's very true. It's before saying, well, you should use C++, first ask, that's respectful, and it's useful, to say, what are the difficulties you find? What do you like best? But what are the difficulties you find with what you're doing now? Let them tell you why they need C++. Then you can show them how it solves their problem. Was that, and you had your hand up too.
No, I had a completely different angle. Whereas, while I definitely agree with Bjarne's and Herb's point, there's two things I would like to say about this. Number one, I don't want to sound like a marketing pitch for my employer, but at Facebook we don't have this problem. I swear to God, the day GCC 4.7 got checked, in, everything is supported was committed to the code base. There's a trickle of lambdas and Veridic templates and whatnot, and so there's very very bright people and very very good who actually can't wait to actually use these new things creatively and gamefully. Which brings me to my point. You're in the position of choosing your job. This has been for many decades already and continues to be a métier in which you have the luxury of being paid for what you love to do, essentially being able to choose your job. If you find yourself in a place where you can't move things, you could just choose a different place to work. And second thing I wanted to say about this, but I did notice works for me personally, is personal example must be there. If you go there and you show that you are more productive with whatever you know than other people, whatever they know, then that is the best way to convince them to try whatever you're doing.
I'd like to say that the problem is so bad that the people come out of high school with a void star attitude. They come out of high school, they think they know everything, they think they know what they want to do when they grow up. They want to write games. And void star is the most efficient way of writing games. They just know this. And if a professor says something obvious, then obviously the professor is not with it. And there are many, many ways this shows up, and in each case you have to figure out what is the individual's problem and what can you do to help it. And sometimes the answer is C++.
So I don't actually have an opinion directly on this, but I do want to share a story because this came up, and it actually comes up a lot in people that I work with. And it turns out that I went to a group because I couldn't believe that they were actually claiming the things they were, because it turns out if you ask them enough questions, you can get them to break through the marketing stuff about Void Star and actually explain what they're really thinking. And it often comes down to very simple misunderstandings. And once you ask enough questions, I kept asking. It turns out that he was like, look, this is performance sensitive. And in the past, I've been bitten by copying objects. The reason why I'm using pointers everywhere is because once upon a time I was bitten by copying objects. Now I need to use, and so I switched to using pointers, and that works, and that makes it fast for me. Right? Now he has personal experience with it, and the only way to counteract that was actually to go further. I was like, okay, so performance is what matters. How can we make it faster with C++? Not just as fast, but faster by using the language. And worked with him to figure that out. And one of the great things about this is whenever people say like pointers avoid copies, I like to say pointers also create aliasing problems. They slow down your binaries. They do not speed them up. The fewer pointers you have, the better your aliasing understanding is, the better the optimizer is about reasoning about your code. And one of the great things about this that's somewhat lucky for me is if you work on an optimizer, you can win this argument by writing code, by compiling it, and by showing them the machine code and stepping through it. And that's actually a really effective way to change people's minds. If you ever find yourself in that position, and I did, gather an audience. Because that exchange is what's going to convince people, right? Gather an audience, work through it, dive in, and then you can really convince people.
You also, you don't need to be a compiler dev to do that. Just use your compiler's option to omit assembler. And if you know assembler, great, you can point out, hey, this is omitting better code, or at the very least you can show, wow, this is emitting a lot fewer instructions. I don't know what they are, but it's a lot less. But that's sort of me, because I don't really know assembler. But I know a bloated code gen when I see it.
Two.
Benchmarking. Yeah.
Quite often the experience
Guess
that make
not.
people shy off from modern code is 10, 15 years old. They used a sort of 2.8 version of DCC, which couldn't do optimization if it tried. It's much better today, but the point is that somebody got bitten 15 years ago. Not only will he not, it's almost a guy, not touch C++, he will, in the strongest term, condemn anybody who even try.
Yes.
Some of these guys are very famous.
I feel like trying to. I feel like trying to.
Nope.
Okay. I feel like trying to repurpose a Reagan quote, which I barely remember, so I'll probably get it wrong. But it's not that our C friends are ill motivated or don't understand. It's they know so much that isn't true.
Yes.
Two.
So that's the Mark Twain version of it. It ain't what you don't know that'll get you. It is what you think you know, but it just ain't so.
Hi there. I just want to raise a question or a concern about the shared pointer. Isn't having reference counting being your mechanism for scope management fundamentally flawed? I just want to point out a scenario that I encountered that I think probably many people are familiar with, is that when you have one object that's referencing another and the other object is referencing back to that object, is not the deadlock that trying to do an unbalanced release to have that object released, is that not far more complicated than defining the ownership of which object actually owns the other object and is responsible for deleting it? And if we make that part of the fundamental language, are we not going to possibly lead people into that sort of trouble?
So yes, shared pointer doesn't deal with cycles. So the usual answers are, remember in C++, most of the time, you have objects embedded by value. An A owns a B by construction because it's a member. You've tied their object lifetimes together and you don't have to worry about it. Now, sometimes you do have objects floating around and you don't know in advance who's going to own them. Then that's when you use shared putter to share ownership. So first of all, limit it to that case. Then use weak putter if possible to break cycles. Then you'll get the deterministic release. But the deterministic release is really important, and it's something that managed developers who understand the problem envy. Having said that, yes, there is that one thing to watch out, and that is the one weakness of reference-counted shared putters.
The nerdy way I put that, that makes sense to people with CS degrees, is that ownership is a directed acyclic graph, and things like X is an object containing a Y, or X has a shared putter to a Y. These are the links in the DAG that say this owns something, and it's impossible for something to own itself. There you're asking for a leak. So to have something having a shared putter that has another shared putter back, that it means that you're not thinking about the structure of your program. And yeah, you use weak putter to break the cycles, but it's not like you're using weak putter as a hack. It's you're using weak putter to express the guarantees that were already there in your program.
I think about it slightly different. I would like to have objects with value semantics optimized by copy. And inside they may have some pointers, but they'll be nice vanilla pointers most of the time because they are just internal to an implementation. If that doesn't quite work well enough, I see, because I have to pass a pointer around, I look for a unique pointer. You can pass them by value. There's for us to pass as an ordinary pointer. They just have a decent release semantics. Only if I can't figure out the ownership do I go to shared pointers. Shared pointers are there if I can't decide whether you or you actually own the thing, and you have to sort of have a treaty about who does it. And you use a shared pointer to settle that. But shared pointer is not my first choice, it's my last choice.
So there's one common pattern that I see that actually yields shared pointer and doesn't yield bugs, and it's not subject to cycle problems either. And that's when the only reason for using shared pointer and ambiguous ownership is due to lifetime constraints. If you have two parties which have their lifetimes pinned by external constraints, right, and they need to share an object, a shared pointer may be the only effective means of declaring ownership there. That's very rare, but it does happen, and it's incredibly important that you have an effective means of supporting that. Often when you end up in this situation, the shared thing is very, very expensive, And the whole purpose of splitting into these two different lifetimed objects was to allow them to not duplicate that expensive entity. You see this a lot in user interfaces in particular.
He said with many more details what the example I was thinking about.
I'll try to answer the question directly. So the question was, what? No, because the direct question was, don't we want to encode in the type system the ownership relationships? And these were not direct encoded in the type system. The truth is that this is a solved problem in research. So there's a significant body of research on ownership systems that are enforced during compilation in the type system. And essentially, they have good guarantees. They provide expressive enough patterns of usage. The only thing is they're rather, let's say, slightly unusual. They're new, and the user is required to do a fair amount of annotation, to add a fair amount of type annotations to the respective pointers. So if you look at that body of research, you see this is not something that your C++ programmer is going to be expected to grasp and use on a regular basis. So I would say it's a practical issue more than a theoretical one.
By the way, it's also language neutral. Because as soon as you have this DAG of objects, Stephan's description is language neutral. This is how you're true of any program in any language that has objects and manages them, and there's this ownership DAG. In managed languages, which tend to say, look, we've got this great garbage collector, which is for raw memory, not for objects, not for resources. It's for automatically managing lifetime of raw memory, not the objects. They say, oh, but we automatically break cycles and do things. Right, that's why finalization is unordered. So the problem still exists. It just has, in some ways, weaker or at least overlapping strengths and weaknesses solutions. So the problem exists everywhere, and you have a choice of points as to how to attack it.
So 3? 3's been waiting for quite some time.
Yeah. Constexpr supports a very small subset of C++. For example, if I have a constant expression and it's calling a function, that function can't use an if. And so I wondered if there's any plans to expand that.
Not by me, and I'm one of the co-designers of Constexpr, and I think people have already tried to turn them into a super macro. One of the comments from the academic looking at the academic paper about it was, why don't you just use an interpreter? Then you can get everything. And basically, Constexpr is an engineering trade-off between what can be done cheaply, effectively, generating good code in the compiler, understandable by users, and expressive power. It would not be too difficult to give you an if, but it wouldn't give you very much. We could give you a loop, but then we have to be very precise about what happens with that loop. And maybe we'll get some extensions in the future, but I have the suspicion that maybe we don't need very much more, and that getting something significantly more would bring too large part of an interpreter into the compiler.
So I want to say, because we're implementing Constexpr in Clang right now, I fear greatly the extension of this feature. Also, we have if, because you can do conditional operators.
Yep.
And so we've already, I know how hard.
We have loops because you can do recursion.
You can do recursion. I've seen a very short, very succinct in-Queens implementation in Constexpr. Okay, it is that powerful already. The problem is not making it more powerful. The only extensions that make sense to me right now are ones which allow you to naturally write a function which is either Constexpr or not, and efficient in both cases. Right? Where it's trivial to make a Constexpr, it's trivial for it to not be Constexpr. Currently, at times, the Constexpr version, if you were to execute it, would be insanely inefficient. It would be nice if we didn't have to write functions twice. That's a noble goal. Trying to get more syntax or more expressiveness, I don't think we need it. We can already express things that terrify me in Constexpr. It's worth noting the complexity of implementing Constexpr is not just the complexity of interpreting it. You must diagnose it. and you must diagnose it accurately. And you know, in Clang, we like to think about diagnostics. Not only do we have to diagnose it, we have to trace back through the execution path that led the user to do something bad. And that becomes very challenging very quickly. And so the amount of memory expended to retain the state is very problematic. Extending Constexpr is very risky in that regard. We've spent more time on Constexpr than variadic templates.
You just partly answered what I was about to ask you. Just with your experience, roughly, you know, breadbox size, man months, how big is Constexpr to implement? You know, roughly, have you found?
I'm not the one implementing it, but Richard Smith has been working on Constexpr for over 6 months now, I think.
6 months, man.
Richard has?
Yes. On and off. I don't know about full time. He's not here. He's going to like correct me. I'm going to be wrong. I can tell this now. But we're not done yet. All right. It's that hard. It is harder than variadic templates. I believe it is actually harder than lambdas. It is one of the most challenging to implement correctly features in the entirety of C++11.
It's interesting to note that it's one of these features that was made more complicated over the dead bodies of its proposers and initial implementers during the standardization.
Say, Charles, can we take some of the tweets, especially ones from earlier? So, for our panelists, when can we expect postponed features like reflection to be standardized and appear? Bjarne, do you have your finger on the pulse of things? And
I don't know. I'm not even sure what reflection is that has been postponed. I don't remember. I mean, there's compile time reflection, which has never been proposed, and there's the runtime reflection, which has been discussed several times, but we backed off because we would have to formalize too much of C++ as a data structure. That was for 98. There is a proposal for simple runtime reflection coming up, and I think there is a proposal for some more compile time reflection, so we'll be discussing it next week. But I won't give odds on how long that takes. One reason is that Herb says we should have no major features in the next release, and that makes a lot of sense. I say that maybe we can have one, and I doubt the committee will be able to agree on one as opposed to a whole lot. So I said, don't hold your breath. It will take time at minimum, or it might take a long time. It's a major feature.
Hello. Chandler, Richard reckons it was about 4 months so far, but close enough. This one's for Herb and Stephan. The difference between pass by value and pass by reference and our value reference from the examples in both your talks.
So what's the question?
Oh, the question was, Herb, you said that passing by value was premature pessimization.
Was that the one with his shared putter that was in red? I actually
Indeed.
wanted to comment on that, and I didn't get a chance to. But hey, look, now I do. Do you remember in my talk where I highlighted the move semantics in green and said, hey, this is the secret one where I'm going to modify the string, and then, hey, it makes sense to pass by value. And then Herb said, okay, always pass your shared putters by constref. I can never think of a case where I want to pass shared putter by value. And actually there is, and this was taught to me on VCSig by someone else. This is how I learned of it. I forget who taught me this. I would have to go look at my email archives. Imagine that you've got some function taking a shared putter to some t. And what you want to do with it is you maybe want to dereference it, but then you want to go push it back into a vector of shared putter. So yeah, you could take the shared putter t by constref and then do a pushback. That's going to copy the shared putter. What if instead you take your shared putter by modifiable value and then you say pushback move sp? In that case, you get either a copy and then a move, or a move and a move. It's the exact same case as in my slide, where you're avoiding an unnecessary copy when the source is already an R value, perhaps returned by make shared. Yeah, you do incur potentially 2 moves, but those are just pointer twiddles. You get 0 interlocked increments. So really the guideline, and Herb's absolutely right, we're still figuring out the guidelines. But I would say at this point, if you're intending to do pure observation, where you're only inspecting the thing, then take by const ref. But if you plan to do something that involves modifying, whether in my example where I'm modifying a string by value and then returning it, or if I potentially want to go move it somewhere, like or copy, it could make sense to take by value and then modify that value, or do a move, which is also modifying.
That's an interesting case, so thank you, as we're all learning this. Thank you for passing that along.
I'm getting
I
more.
think if I update my slides, I'm thinking, how do I do it? Do I just say, in a few rare cases without explanation, or do I add a new slide saying, okay, now there's this corner case that may happen, and here's a full slide explanation for it?
I would subtitle it, and so you want to be a library developer someday. Because really, if you incur an extra copy, it's not the end of the world, unless you're in an inner loop where it really matters.
But I'm really confused. Maybe I'm getting something wrong, but this is really old news. If you want a copy, you better. If you want a copy in your function, whether you want to escape it, in the case of shared pointer, or you want to mess with it, as in the case of Stephan's, I'm going to mess with the string a bit and then return it, or you want to swap it with whatever state you have, then you better take it by value in the first place. It was in Mojo like years ago. It's in C++ config standards. And Herb, you forgot about it.
No, I didn't forget. I didn't forget about it. I knew about it. I was waiting for you to say it.
Destroy.
It's.
It really depends on move semantics.
It is not, and this was before move semantics too.
Right.
At the time, you might remember that each time that it was mentioned, we said yes, it's right. It would work. It is not controversial. It is not uncontroversial, but that is good advice, and it makes the code unusual and more difficult for developers to understand.
Right.
So
but the old
reason.
unusual is the new usual.
that
negation
may be
of the
true.
negation. What's that? Hegel's, dialectics.
I'm getting more and more worried about shared pointers, and I think you guys are spending too much time with them, and maybe you should spend a little bit more time figuring out how not to use them.
I think I was actually
or how
hold
to
on.
use them very simply.
This is not about shared pointers, though. I mean, shared pointers exacerbate it, but it's any object.
string, like in my example.
If you want the value, better take it by value. That's
And I think actually Stephan had a great observation. If you're only going to observe the value, if you're not going to change it, send it somewhere, destroy it, move, like anything you do to the value, like when you're doing something with the value, always take it by value, because you need the actual value. If all you need to do is see it, that's when you want a reference. That's when you want a const reference.
Yeah. Great.
Great. Number 2.
A practical question mostly for Herb. Libraries, the lack thereof. There might be some people here and some people watching online who are able and willing to help close that gap, but who also want to put food on the table. What sort of advice would you offer those people?
First, please email. Let me know. If you are a zlib, thanks for mentioning that one that I forgot from my slide, Boost, Adobe, Apache,
Poco.
Apple, Poco, yes, I had that one on my slide, and so forth, developer who has access to in-house libraries that, that could be contributed or just want to help, and please let me know, because that's what we're trying to put together. We have a spreadsheet with the list of the features we want. Only half of them are filled in with existing practice, and smaller than that with people who are able to contribute work on them. So if you have time, it is not expected to be a full-time job, but it does require help. And so that's the thing we need most, is expert help. I happen to know you fall in that category, so I'm hopeful to pry away some of your time. Thank you for offering.
The other half of the question was the food on the table part.
Well, that's why I said not full-time, because food on the table, it's unfortunately standardization, believe it or not, is a volunteer effort, and companies like Google and Microsoft do contribute much of our time to do it, to move it along. And other experts come on their own dime, as you know, and they contribute from their own free time or their own work time they take away from whatever else they were doing. So it's all volunteer effort. It's interesting to see this kind of project and how much has been done in C++11 on an all volunteer basis. And people who say, well, why didn't you design this completely and why didn't you do this whole, don't always appreciate that.
No. And I mean, they say, well, why don't you treat it like a proper project? Okay, you have project management and you just follow the schedule. Look, how do you do a project in the traditional way with no reward structure, no punishment structure, no way of keeping people there, no way of assigning work, no way of kicking people out when they slow things down? None of this is available. We are herding cats, and we may be considered very good at it because we are delivering, maybe not quite on the day you would like it, but we tend to deliver reasonably good thing in not too outrageous timescales.
I have an idea for punishment structure. The next person who tries to add something to Constexpr, they get to maintain the IOStreams wording. Just give it to them.
So Herb, can you read the question from Twitter?
What is the plan for modules? What problems make them complicated to have? How will they be solved? Anyone want to? We talked a little bit about it yesterday. But
I'll wade into this one.
Yeah. Sure.
We don't know what modules are, and so it's hard to have a plan for them. We have competing ideas of what modules are. I think we have to figure that out first. The problems that make them complicated to have is that I think modules are going to inevitably be one of the most syntactically invasive changes to the language, because unlike a lot of changes, you think about changes to the syntax, right? We like changes that are inside the syntax, right? Because they're easy to kind of incrementally grow. Changes to the outer edges of the syntax are really far-reaching. If you imagine like changing the syntax is going to impact every declaration, that's really, really invasive. And I think all of these things kind of combine to make it an instantaneously heated discussion. And I wish we could keep the heat away until we actually figure out what we're discussing. Because I've heard at least 4 different problems, like capital P, problems that modules are going to solve, and at least 2 of them are mutually exclusive. So it's very, very confusing to even talk about modules. I think we need a lot of time and thought before even. There's no plan.
I agree with that, and I'll say that's actually a more general problem than modules.
True.
When people come and they want X, doesn't matter what X is, everybody thinks about X, of what it solves for them. And as soon as we come down to a concrete proposal for X, we'll find that it actually is not the ideal X that you were thinking about, and you were thinking about, and I was thinking about. It's sort of a concrete thing that almost does what I like, but not perfectly. And at that point, support for X drops. Sometimes for 2/3 of the people walk away in disgust because it wasn't their X. And modules suffer for that, at least to a large extent, because he said those 4 variants of it, and I think the number is conservative.
It's probably growing as we're talking.
Yes, and people expect so much and mutually exclusiveness of modules that it's a very tricky issue to deal with.
Fortunately, world peace is not one of those problems, and he plays in the NDA now.
Yeah, at this point in time, you never know.
One.
Why didn't move semantics pass into lambda capture? For example, it is impossible to pass a unique pointer by value.
I asked the committee for that. They said it was dangerous. I disagree still.
You can't pass a unique pointer by value?
No, because it would attempt to copy.
Yeah.
If you try to say bracket UP bracket, that's going to try to copy the unique footer, but it's non-copyable. You can capture ref to unique footer, but that doesn't move from it.
Yeah.
Oh, why can't you just move it?
Yeah, I would love to be able to say bracket ref UP.
That's what I thought it was doing. Well, sorry.
Yeah. Hey, you got to vote on the committee.
So that's what it does everywhere else. But this is an example of where we've got a pretty high quality standard, but we still need to work out some interactions because the committee was conservative. We wanted to ship. Shipping is a feature.
Yes.
Anybody who works on a product knows this. It was very close, by the way. C++ 11 was this close to being C++ 13 simply because a lot of people said, well, let's just have one more ballot, which in ISO means add 2 years. So a lot of us fought against that and prevented it. That's why we have C++ 11.
Yeah, so
but you need to ship.
If we get just another couple of months, or just another couple of meetings. It'll be perfect.
So one of the things that we are now going to go back and do is say, okay, the things that we weren't sure about, because including polymorphic lambdas, which were discussed, but we weren't sure how they interacted with concepts, and then concepts left, but it was kind of late, and things like R-value move capture, those are things that we need to start talking about again to finish the fit and finish, the polish of the interactions in C++11 features. It is better, by the way, this is a good place to be. It is way better to have, in the language side of the field, not so much library, but in language, to not have a feature than have it misspecified and that you have to support forever. And then you've taken that hole and you can never get a chance to do it right.
3. Hi, thanks gentlemen for coming and doing this. We really appreciate it. I'm new to cross-platform development, and this is a bunch of experts in a variety of platforms. Can you share some tips and tricks for managing projects and using multiple compilers and a lot of these other things for getting C++ code to compile across many platforms simultaneously?
Let me just be the first to throw in, isolate your compiler and platform-specific stuff in a single platform.cpp or module as much as possible, and then write portable ISO C++ everywhere. Everybody's going to tell you that.
Yeah.
But isolate it. That includes all Microsoft extensions, including C++ CX. That includes all GCC extensions. That includes Solaris extensions. Well, anyway. So
You have to go to Solaris.
But definitely isolate that. And then you have your 95% portable code, and then you just re-implement this for each new compiler or platform. Isolate yourself that way.
And compile everything with all the compilers often.
Yeah.
Don't get it to work on one platform and then port. That's the wrong way.
It also helps to avoid extensions that aren't absolutely necessary, like VC's 4 space each. I viewed as very bad because A, it was not portable, B, it just replaced, a handwritten iterator loop, which is more verbose. But is that really worth the cost of non-portability plus a fragile extension? Extensions often tend to be not nearly as well tested as portable code that the whole world is going to constantly test every time they use it. But if it's an extension that buys you something like decal spec DLL export, and if you want to use a DLL, then okay, use that.
I'm going to jump up on a very tiny soapbox and say, I think one of the easiest traps to fall into when dealing with this is to think that your build system will save you. A lot of people like, especially in the open source world, we have configure scripts, and our configure scripts craft portable bits of code for us, and our make files are enormous and pull things together. This is a trap, and it's a trap laced with very dangerous toys. Okay, don't go into that trap. There are easy ways to write your code in a portable fashion, even when you're writing the code in the isolated part of your code base, and it is isolated, which has to deal with platform-specific dependencies. Every single platform I have ever touched has preprocessor macros that the toolchain provides, which clearly and specifically identify that platform. You don't need any scripts to get these. You don't need any generated files to get these. They always show up. There's actually a great database online you can go to. They've collected all of them. You can target platforms from HPUX across Solaris all the way through old versions of Windows, new versions of Windows, weird versions of Linux. Don't let yourself be fooled into the popularity of build systems. There's a better way. And it's in the language, and that's why it's better, because it's actually in the language.
Great. Number 2.
First of all, thanks for all the speakers and the respective companies, and special thanks to Microsoft to make this happen. There is a saying I like, and I don't know if the translation will be correct. No one is prophet in his own country, or company for that matter. So you guys can be prophet in my own company. There are people at my company that believe that STL is somewhat a third-party library and that has portability issues.
What?
Yeah. And therefore must not be present in APIs. So STL is a bad press in my company, and in my opinion, a large underusage of classics like std vectors. My question is, are they right to consider STL a third-party library? And if not, how can I convince them of the opposite? Thanks.
Let me take this real quick.
14882:1998 . It's an ISO standard, has been for over a decade. Go ahead.
That was easy.
I feel like I need to hold you back.
Show them the ISO standard.
They all start with STD : : That's a hint. It's not like third party or like janky software : I don't know. Like,
it used to be the case that compilers would not ship with standard libraries, and you would have to graft on something else like stelport. But now every compiler comes with a homegrown implementation like VC or GCC's libstd C++. Kling's got a libc in development, I believe.
Yep.
And it's many users don't even realize it's a separate thing. To them, it's just part of the language, and they are built to be the absolute highest quality.
I mean, it's about 14 years since it became standard and started shipping with everybody.
Andrei, next time I will not do that. But please say what you were going to say.
No, I was just 2 words for him. Contact headhunter. It's not the fight worth fighting.
Now having said that, some people, this is not it's not a third-party library, you should use it, but when you said in interfaces, like on module boundaries, remember, all C++ class types have trouble there. Yeah. So it's people talk about why can't I put string on a stinking module boundary? Well, because you're sensitive to implementation, and that happens to be the one with the most variable implementation in the whole standard library. So that might be part of what he's saying. Other than that, Andrei's advice is good.
Go for it.
So when considering new language features for inclusion in the standard, how important are compiler vendor concerns and the availability of existing implementations? And were there any compiler vendor concerns about C++ 11 features? And what happened to export in that case in '98?
Whoa, I'm not going to start with that one.
Yeah. Next question.
Well,
no, it's a good question.
Maybe I should say something about this because, well, I don't have any opinions on it, do I? Anyway, I think de facto the compiler vendors and the library vendors have a veto power. And in many cases, they are very conservative in what is accepted. There are some that are so conservative that the language wouldn't move at all, if that was the case. So if you're worried that things are pushed in over... Now, I think that's a conservative body, and they have a major say in things. Export was a compromise, and it turned out to be not a good compromise. Some of us wanted separate compilation of templates, others didn't. And the compromise was probably worse than both alternatives. The compiler vendors that implemented export eventually decided it wasn't worth it, and they proposed a withdrawal. The EGG implemented export, did it very well, very professionally. They then proposed that it be removed because it was a burden to them and to the community, and vetoed attempts to just deprecate it because that would still be a burden. They wanted it really gone. And I think it was the right decision.
And EDG are heroes, by the way.
Thank you, EDG.
Because Edison Design Group, always been long the most conformant C++ front end. They don't have the complete compiler, they make the compiler front end. When export was being debated, every single compiler implementer argued strongly against it. It went in including EDG, and even EDG led the charge against it. It was voted in anyway, and they spent 3 man-years implementing it. That is honor.
It wasn't 3 men, it was 3 David years,
Yes.
okay? That's different, it's much more than that.
And so we gladly deferred to them as say, look, you're the guys who did the work. We'll do whatever you say. And they said, look, it's better for us if you just yank it instead of deprecate it. So we said, it was unanimous.
Let's go to 2, or not?
No,
Please talk.
Go ahead. Oh, okay. Also, in other cases, we clearly went out of our way to support all the different vendors to make sure that nobody was severely handicapped as a result. So that's actually fairly apparent if you look at the atomics definition in the standard. There are various low-level possibilities there, which are intended to ensure that basically you can write very efficient code for every possible vendor's current implementation.
So do you have any advice or strategy for companies who have to support a very cross-platform, very wide range of possibly very old compilers like Visual Studio 2003, that the likelihood of seeing a C++ 11 feature actually in production use is possibly years away? Should the language have offered something so we could like if-def it in, though that even sounds kind of ugly? Or should I just throw up my hands and say, I'll come back in 2016 and I'll think about C++ 11 then when I've retired all those old compilers?
It's very hard to fix problems when you can't touch the compiler technology. Mm-hmm. If people insist using a 10-year-old compiler, well, you're using a 10-year-old language, and you'll have to consider whether supporting that system is worth what money it brings into your company compared to the cost it imposes on you for being unable to do better across your user community. It's a commercial decision.
3.
I think this is another time when his mantra kicks in. You should ask yourself, like, why?
3 is a bit of a low number.
Right? Like,
although I should point out, I remember in Herb's slides, he mentioned that external templates are supported in VC10. That's actually not true. They were originally supported in Visual C++, I believe 2.0, John Case told me, which is... So you have external templates. Hey, hey. That's a C++ 11 feature. 1911.
Having said that, 2 of the compilers that stuck the most, which, yay, they got great adoption and traction for C++ developers. Unfortunately, then people got stuck there, were GCC 295.3 and Visual C++ 6, which as of our previous release was still our compiler's biggest competition from 1998.
3?
Number 3.
Yeah, I'd like to go back to the keynote and the question asked there about what is the greatest weakness of C++. And the follow-up presentation with Clang kind of teased around the edges of this. And to be completely fair, I don't know that it's a weakness of the language, but in the application of the language. And that is the single-pass preprocessor and having to fully declare or define objects before using them. And the result of that being a dependency graph in your includes. And woe to the programmer that ever has to change that on a very large project. And this is really work that you're doing that doesn't ever express the ideas. It's basically maintenance work that you spend many, many man-hours dealing with. I was kind of curious if there was any thought put into that.
Yeah, so I have a lot of answers to this. I have at least 2 answers to this. So the first one I want to answer is the idea of single-pass preprocessing and linear compilation. And this one I'm going to answer from the perspective of a compiler implementer. And when you're implementing a compiler, I really want those, and for a surprising reason. So I'm glad you asked this, because this shocked me when I understood this part of Clang's implementation. It is crucial to the performance of the compiler that the preprocessor be single pass, that the compilation be single pass, that it be forward moving, and that you preprocess as you parse, because of cache locality. By doing single pass compilation from the top down, you ensure that every semantic structure you are most likely to refer to, every AST node you're most likely to query, every token you're most likely to manipulate is almost assuredly in cache. The compiler is much faster because of this than it would be otherwise. One of the slowest things to do in Clang is to do tentative parsing, large amounts of tentative parsing, because that disrupts this single pass parse and it loses your cache efficiency. I was stunned by how important this was to compilation performance. To give you an idea, when you don't do tentative parsing, when you don't get any of these weird scenarios, and template instantiation, templates are not one of the weird scenarios, like keep that in mind. As long as you're not in that situation, parsing C++ is almost as fast as decoding a binary representation of the AST off of the disk. All right? That is shocking to me, right?